Okay, so now prepare for Nmap to start being really slow. Yeah, so even with my 100 meg uplink, I guess it will take some time to scan even those 33 hosts. So let's start to do that and see what happens. So of course we will use this live hosts list we have collected, and let's first try to do all ports in connect regime. So the mode is full connect now by default when we are running as non-root users, but let's put it here explicitly. And let's of course save it to open ports files. Okay, so we start that, and you can see, yeah, one important thing. Since we have already discovered all the ports, all the hosts, and they are active, we will assume that they are up. Okay, so we will not ping scan them before that, and we can do this as well. We can just deny all resolution in a way. So as you see, it takes a portion of 4 hosts and starts scanning them. And this scanning process is really slow. As you see, we are like on a fraction of a percent right now. In 20 seconds, we have as much as a third of a percent complete for the first host. Okay, so this is slow. I think you agree. And the first 4 will be scanned in an hour. This estimation is rough, but 45 minutes and counting down, but still. It can hang in the very late stages and be there for a few minutes. So, I hope you agree that it is not practical to wait for that to end for the sake of this video, but in the real life, on the real engagement, you will have to do that. You will have to really wait and see what are all the open ports. Okay, so this is something to do overnight, I guess. Let's instead take like a fraction of our hosts. Yeah, so let's take, I don't know, 10 of them and save them to just live LST and use that to do our connect scanning with top 100 ports. Okay, and do some service fingerprinting and save to open ports. Okay, yeah, that's it. So this time it's much faster. You see that it's scanning all 10 in parallel. So estimation is really optimistic, but this is just connect scan timing, as you can see. So it has ended the first stage, and now it's service scanning them, which is just fingerprinting and comparing to what it already knows about the services on the internet. So we have chosen not a really good place for our exercises. So this is quite a homomorphic environment of a network of open REST web application services. But still, you get the idea. We have something that is open on traditional HTTP and HTTPS ports, right? So it's I guess it's got some kind of API gateway that is that the web applications and the mobile applications are connected to in order to get to Yahoo services. Okay, and now when we have these outputs, let's maybe increase the amount of information, and I will show you how you can process them after that. So let's use the same syntax but increase the number of top ports. Maybe something is there in the end. And let's add up this SC, S capital C switch, to do some basic HTTP scripting, yeah, because only HTTP services are identified here. So let's save it to open ports and scripts. As you see, connect scanning takes much longer, just because we have increased the number of ports by 2.5. Okay, it's over, and now service scan takes longer. That gives me hope that there is something more than just 2 open ports and all these IP addresses. But for the sake of the example, the number of ports doesn't count really, right? So you'll just be able to practice these skills in the environment you have locally. Okay, so nothing really added up to what we already had, but now we have more sophisticated results. So this is Tumblr. Okay, so this is Tumblr, that is like a blogging platform, right? And we just were not very lucky. This is like, most probably it's a high availability load balancing equipment, yeah, that is using OpenRest as at the front end on HTTP protocol, and that's how it looks like. This is the basic service fingerprinting that is provided by -s capital V, and this is a script output. So first of all, it's a script name, yeah, and it's its output, OpenResty, and the title is absent. So most probably if we open that, we will not see anything on the page. Here the header is the same, the title just redirects us from HTTPS to HTTP, which is unusual. Normally it happens the other way. And there is a SSL certificate, of course. SSL is configured, and we know that the name of the host is somewhere here, but we already know that because there is a redirect, and there are alternative names, and there are validity time range, and yeah, there is some service information. So it's pretty much equivalent for all the hosts, but let's use it as a good example to show you how to generate nice reports from what Nmap output looks like. So playing around with text is okay, but in order to make stuff more readable, you would like to transform that to hyperlinked HTML. Okay, so there is this tool that just processes the XML files in order to generate HTML code based on the templates that these files contain, or you can give it to them manually. So normally we have this kind of output, yeah, so style sheet is locally stored, So in order for XML processor to know what all these tags mean, it needs to have a style sheet, and style sheet is here. So we'll use default style sheet and process the XML in order to generate HTML. So let me remember the tool name is XSLT procs. So it's XSLT processor. We will give it this open ports XML file, and it will basically, as you see, generate some large table of HTML. Okay, so we will create this open ports HTML file and open it. Let's see what happens. Okay, so much nicer, right? Everything that's in there is presented nicely, and this is without our script output, yeah, because it adds a lot of data. Let's see what happens when we generate another file. Like this. Okay, we can browse through different file names and IP addresses and see everything that's in XML file or in normal output structured as this. Of course, you can play with this XSL template and even highlight vulnerability results when you find them. So there is a really flexible functionality you can use. You can search for notions of vulnerabilities or specific output data that you seek for, yeah, in Nmap output, and highlight it with different color. So yeah, there is no limit to using XML in this regard, but security people are not really fond of XML in general. So if you do that, you will be ahead of the crowd by a few steps. That's definitely. Okay, so I hope now you see how we can discover and fingerprint the hosts and the services. And the final thing I want to show you is just what the results of operating system fingerprinting may look like. For that, let's use the same input, but let's limit the time we spent for port scanning, because we already know that nothing is really there. Let's do this like this by scenes, and let's add this service, this operating system discovery, and send it to a separate file. Okay, first of all, let me show you an error. Okay, it requires root privileges, of course. So let's run it in sudo. Pings can take some time. Yeah, let's do it another way. We have to assume that everything is up. DNS resolution. We have to skip DNS resolution. Okay. So since scan was really fast, we didn't even notice that. And now service scan timing is almost done. And now network script scanning. SE stands for Nmap scripting engine, of course. It takes some time, and then there will be operating system resolution, yeah? No, it's doing it somewhere in between. So you see there is this notion of aggressive operating system guesses. This is a warning, proceed with caution, following results could not be firm and concrete. So yeah, there is some special purpose device that is running most probably Linux, and even the kernel number is not certain in this case. So normally it's much more precise, but here we can guess that this is some old version of Linux. Old because it's embedded, and it's still limited in functionality because security patches are most probably there, but catching up with the vanilla kernel versions is not what embedded distributions are aimed at. So yeah, let's now process that with XSL. Okay. Now you see it's much nicer. Okay. So based on one open TCP port, it has somehow prioritized for us that, yeah, that is most probably Linux between these version numbers. Okay, okay. At least we know it's not Windows. We can be sure of that. Okay. So these are different ways of using Nmap for service and service enumeration and operating system fingerprinting. Let's wrap it up for now, and let's proceed to the next demo where I will show you how to extend Nmap functionality with scripts, and then show you some alternative tools that may come handy in very specific cases.